So I'm going to give you a brief definition of scientific notation, and then there's a key part that I hope will help you to hopefully help remind you, is this number scientific notation? You can answer that yes or no based on this definition. So first of all, scientific notation is used with numbers written as the product. So now we've seen product many times in our chapter, of a factor and a power of 10. The product of a factor, and I'm going to put this with factor. You've probably seen this on some things, right? That little asterisk. And a power of 10. So numbers that are written as a product of a factor and a power of 10 are said to be written in scientific notation. Now, do you guys know what that asterisk means? John?
Yeah, it's like important.
Okay, it's important. Jack?
Like in the Bible, there's like little letters at the bottom of your page.
Yeah, sometimes they have like a little letter like A, and then they have A down here, and there's a note. Jensen? Yeah, there's something specifically about this word factor that I want you to pay attention to. Now, do you see the note down there? No, because it's not written yet. So now I need you to pay attention. After we talk about this definition, what do I mean by factor? Okay, so do you guys remember what product refers to? Sophie? Multiplication, all right? You have two things being multiplied. You have a number, which is called a factor, and a power of 10. Does anyone remember what a power of 10 is? So a power of 10, you can give me an example, or you can give me like a definition, if you can come up with something. Power of 10, what's that? All right, John?
10 to some exponent.
Okay, 10 to some power. Okay, 10 is a power of 10. 100 is a power of 10. 1,000 is a power of 10. Can you give me the next one? 10,000, 100,000, million. So you can also put it in this way. 10 to the first, 10 to the second, 10 to the third, 10 to the fourth. Those are all powers of 10. Okay, let's go to that little asterisk, since you guys are dying to know what that factor means. The factor, not just any factor, but the factor must be greater than or equal to 1. I'll make 1 clear, and less than 10. Sorry about the writing on the bottom. That's greater than or equal to 1 and less than 10. What are you trying to do here? Okay, there are two numbers when you have scientific notation. One is a factor, and the other number is a power of 10. Power of 10, very clear to see. 10 to the 0, 10 to the negative 5th, 10 to the 12th. But that factor has to be a number that is greater than or equal to 1 and less than 10. This is how I think of it. It has to be a number between 1 and 10. Or it could be 1 itself, okay? That's got to be a part of your scientific notation, or it's not in proper scientific notation. I'm going to keep referring to this over and over again, and that hopefully can help you. Mr. A, how do you know if the decimal place should go here? Well, does it answer this question? It does. Great. It doesn't, got to change it. So you got to get this down. Factor is a special number, and it has to be between 1 and 10. Has to be. Okay, you guys good with that? All right, let's move on. Let's look at example number 1, and I think that's at the bottom of the page, example 1A. All right, we're going to start with big numbers. Why do we use scientific notation, by the way? I gave you a hint. Because you have sometimes really, really, okay, long or big numbers. Do you guys know what other subject uses scientific notation?
All of them.
All of them? I like that, all of them, but specifically?
Science.
Wait. How'd you know that?
I thought it was science.
Scientific notation. So scientific notation is helpful in science, but we use it in math. And it is found. You can find it in other places too, but scientific notation is scientific, found in science. So we're going to call 687,000 a big number. Okay? Now you're like, but what if it's like grains of sand? Well, it's still a lot of grains of sand, 687,000. I'm going to define big as anything greater than 1. Can you guys remember that? Anything greater than 1 is big. So anything less than 1 is really small. Okay, so can we stick with that? Because that's going to help guide us to get these numbers very easily, scientific notation. All right, I want to write this in scientific notation. Right now it's in standard form. That's how you normally see a number. So I want to make it a product of a factor and a power of 10. So it's going to look something like this, with some number here and some power right there. Okay, what does this factor have to be? Look at the asterisk at the
Greater than 1.
greater than or equal to 1 and less than 10. Okay, is this number right now in between 1 and 10?
No.
All right, I can move the decimal place right here so that this number becomes a number in between 1 and 10. How many times do I have to move that decimal point? Everybody.
5.
All right, I'm going to move it 1, 2, 3, 4, 5 times. Okay, that becomes 6.87. Can I ask you this question? Is 6.87 in between 1 and 10?
Yes.
Is it in between 1 and 10? It is. Is there any other place I could have moved that decimal point where that number is going to be between 1 and 10? No. You could have moved it here. 68 is not in between 1 and 10. You could have moved it here. 0.687 is not in between 1 and 10. The only place it goes is right there. All right, how many times did I move it? 5 times. You're done. Scientific notation is complete. Yes. That's when you're talking about what kind of numbers? Yeah, whole numbers is
Are we gonna have to
big
work
number.
out a problem and then do scientific notation on the answer?
Braden, that's a great idea. No. Can you say that again? No. Okay. We'll figure it out.
What if you have a number that where you don't move the decimal?
So
Or would you not? Yep.
sometimes you do. They'll throw like a tricky one. I don't think you'll get that today, but we can talk about that. Let's go to the next example. But the answer here would be 6.87 times 10 to the 5th. This number is scientific notation form of this number, 687,000. All right, I'm going to give you a couple hints to help you out. When you're talking about a big number, what do we mean by big again? Any number that's greater than 1. You're going to have a positive exponent, okay? If it's a positive exponent, big number. All right, let's do another one with B. B is, oh my, what's that number? 50 million. And I hope you agree that's a big number, no matter what you're talking about. What do you mean if you're talking about cells? That's still a lot of cells. Okay, that's a lot of cells. Yeah, subscribers to my YouTube. Not quite. Okay. Minutes of YouTube video I've recorded. Not quite. Okay. 50 million is standard form. I need to write in scientific notation. So it's going to be times the power of 10. All right, how many times should I move that decimal so that number becomes a number between 1 and 10? How many times should I move it?
7.
All right, let's see here. It's right there. So I'm going to move it 1, 2, 3, 4, 5, 6, 7 times. So I'm going to write it as 5. You can just leave it as 5, or you can say 5.0. It's still 5. And then how many times did I move it? Okay, before you circle it, let's verify some things. Is this a product? Is this a product? How do you know it's a product? It's a multiplication problem. Is it a number times the power of 10?
Yes.
is that number or that factor in between 1 and 10? Okay, so we're good. There's no other way to write that in scientific notation. It's 5 times 10 to the 7th. All right, is this a big number?
Yes.
So you have a positive exponent? You okay with that? All right. Let's go to example 2. Let's go straight to example 2 because those are dealing with, what kind of numbers do you think I'd classify example 2 as? What kind of number is that? It's a small number, okay? Can anyone read that number for me? That's hard to read it properly. Don't just say 0.0000. There's a proper way to read it. And once I write it down, we'll talk about it. And I need to make sure I get the right number of zeros. 1, 2, 3, 4, 5, 3, 5, 7, 6. Okay. 1, 2, 3. Okay. What's the proper name? Okay, John, go ahead.
3,576 million.
Close. It's 3,576 billions. Billions, super close. And the way I figured out, because like either you go tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, you can do that. But there's a little trick. I pretend this is just one big number. 3, 6, I have 9 digits. I add an extra, that's 10. The 10th place value the other way is billions.
Wow.
So whatever it took, you can just count it by each place value, or if you have tricks, you can use that as well. Okay, big or small? Okay, like if we're talking 3,576 billions, we're talking about, I don't know, like the size in inches of a cell, the width of a cell, or even like the width of an atom. Like that's pretty small. So my exponent in my answer, what do you think it's going to be? Positive or negative?
Negative.
Negative. Okay. So it's going to be times 10 to some power, and we said it's going to be negative. If we're correct on that small number. How many times do I move that decimal place to make this number go in between 1 and 10? There's only one place I can do that. Mackenzie?
5.
Okay, let's see. 1, 2, 3, 4, 5. I'm going to go one more 6. That's that negative 6 power. 3.576. So is 3.576 in between 1 and 10?
Yes.
Mm-hmm. Is this a multiplication problem?
Yes.
Is this a power of 10?
Yes.
Mm-hmm. 10 to the negative 6, which is a small number. And yes, this is a small value. Okay? Big numbers have positive exponents. Small numbers have negative exponents. What do I mean by big and small? Greater than 1, less than 1. What about 1?
That is
Greater.
It's less than.
it's
It's
equal.
It's a big
Okay,
number.
someone said the right answer.
Smig number.
It's a big one.
I call it medium. No, it's actually, I consider it still a big number.
Haha.
Yeah, so it's a big number. But thankfully you won't get too many of those easy problems. All right, I want you guys to work on page 319. Simply do numbers 8 and 9. On 319, do numbers 8 and 9. Change those both into scientific notation. What kind of number is 8? Big or small? Small. So it has to have what kind of exponent? Negative. What kind of number is 9? Big. It's bigger than 1. So it's got to have a positive exponent. And remember, just tell me how many times you move that decimal point. Sometimes it was written there. Sometimes it wasn't. So just be careful with that. Okay, Elizabeth, what'd you get for number 8?
4.5 times 10 to the negative 5th.
Okay, let's see. 1, 2, 3, 4, 5. So that's where the 4.5 comes in. Negative fifth? How'd you get negative?
Because it's smaller than 1.
Oh, yeah. Okay, done. How many of you got this for number 8? Okay, so you get how to do small numbers? All right, let's see if you can do big numbers that are a little bit tricky. Yeah, or bigger. Yeah. Oh, ooh. Caroline?
I got 8.479 times 10 to the second power.
The second? How'd you get the second?
It's greater than 1.
Okay.
Or
Twice. 1, 2. Yep, so we moved it twice. That's where I get the 2. It's a big number, positive. 8.479 times 10 to the second. How many of you got that? Okay, good. Questions? Yes, ma'am.
So, if like the number, so if you go to the right, it's negative left. But what if the decimal is already in the place where you make it between 1 and 10?
So and that's I think what Caroline asked before. Let's say the number was 8.479, right in scientific notation. Okay, so do you have to change the first number? No, because it's between 1 and 10. But you do have to write it as a product, and this is where, how many times did you move that decimal? How many times?
0.
That's proper scientific notation. Now, some of you are saying, but that doesn't make sense. It's not like 10 degrees. No, 10 to the 0 power. Does anyone remember what 10 to the 0 power is? Show me with your fingers. Okay, I see 2 answers. There's only one correct. There's only one correct answer. One correct answer. One correct answer. 1 is the answer. 10 to the 0 is 1, so listen carefully. A number times 1 is which property? Identity property, right? So that's what it is. You didn't move it, did you? So you write 0, and we already know that that's 1. Any number times 1 is itself. So does that answer your questions? Yeah. It's funny. This is going to be cool, because when I look at this problem, like, right, we get this, right? It's not too tough. So in Algebra 1 or Algebra 2, you start getting these numbers where you have this number times this number. And then divided by some other 2 numbers that are big and small. And then you have to give your answer in scientific notation. That's hard. It's not hard if you know how to put them in scientific notation first. It's very easy, in fact. Because even a calculator, if it deals with these numbers too much, you start getting this little answer on your calculator that says it's E or EE. It's like, enough. Stop giving me numbers. You can't handle it, but you still can handle it because you know scientific notation. All right, example 3, because I'm thinking, man, this is not too hard. But example number 3, what do they want you to do in these problems? Yes, write each number in standard form. So they already gave me scientific notation. Yes, I got the answer. It's 8.495 times 10 to the 5th. Got it. Done. But is that what they wanted? They don't want scientific notation. They want standard form. Now, is this a big or a small number? It's a big number. How do I know that? Positive exponent. It's a positive exponent. So, this is the most common question I get with scientific notation. Mr. A, do you move the decimal to the right or to the left? I guess both ways aren't correct. So let me show you what you would do. All right, you see this? You see this decimal point? If I started moving it to the left, what kind of number does this become? Small. But was it small? No. So I needed to go, 3, 4, 5. You see these empty spots here? What do you put in those places? So you have 8, 4, 9, 5, 0, 0. Put your commas where they belong, and that's your number. Is 849,500 a big or small number? It's a big number, and that matches. Your alternative would have been to move it to the left, and you would have gotten .0000849, and that's a very small number. which doesn't match that. Yes, ma'am.
You said it was incorrect if you move it both ways, so how is it incorrect if you move it right?
Sorry, if you move it, like if you try both, if you do to the right and to the left, you're going to get two different numbers. You can't do that. You got to move it one or the other. Yeah, I probably should have said that more clearly. So you can only pick one or the other, not both at the same time. All right, so this is your answer for 3A. And then 3B, big or small number, automatically?
Small.
Small. So if it's a small number, where should I move that decimal, to the left or to the right? You're like, I really don't know. Like maybe tonight you're working this out. I don't know. So you start moving it to the right, 1, 2, 3, 4, and you end up with a big number. But does that fit? No. So 1, 2, 3, 4. So you put your decimal point, 1, 2, 3, and then the rest of the digits go where they belong. And is that a big or a small number? It's a small number, and it matches. Sorry, it matches your exponent there. Okay?
So we leave that number at 2 decimal?
Yes, because this is standard form. This is how you normally look at numbers, and it's really cool, guys. If and I should say when you get into science, you're using these a lot because in science you're dealing with really, really big things like the distance from here to the moon. And because I just looked at this recently, is like 1.5 light years. I mean, that's not. I mean, that's kind of far, but it's not tremendously far. But like, what about from here to Saturn? I mean, it's several thousand, maybe million light years away. And I'm thinking to myself, you can write that number in standard form, or you can use scientific notation. That's for like celestial, like outer space things. And then when you think of like atoms and molecules and cells, super, super small. So you get your little inch ruler and you start trying to measure it. You squint because you can't see very well. And you focus, quiet. And then you realize, wait, that's not going to work. So you have to get a smaller instrument, smaller, magnify it. And then you realize, compared to an inch, very, very small. So we use these all the time, and it's really cool because that's how things are. So when someone says, this is not real world stuff, I'm like, actually, it's very real world. That's what our world uses. Fractions, decimals, big and small numbers. All right, do you guys have any questions on these?
What's the number?
That's the okay. Your wish is my command. 15 to 33 odd.
Whoa! It's not very much.
Wait, he's gonna sign up?
And 40 to 43. And that's paid, it's not too much, I hope. 319 to 320. All right. And you guys can ask for help. Goodbye.